Hello, class. In today's video, we're going to be talking about what are called initial value problems. So I thought it best to start immediately with an example of what is meant by an initial value problem. And so we have here, if big f of x is an antiderivative of little f of x, which is 6x squared plus 6x, and big F of 1 is 9, what is big F of x? Okay. So here we're given basically the derivative of big F. The derivative of big F is 6x squared plus 6x, and we're asked to figure out what F is. And so you might remember, as we've been talking about, every time we've done an antiderivative, which is just the same thing as an indefinite integral, we've tacked this plus c on the end. And we've tacked the plus c on the end because there's lots of functions whose derivative is 6x squared plus 6x, or any particular thing. Okay? And so in order for us to ask this question, what is f of x, definitively, implying there's only one answer, I need to give you an additional piece of information. And so that additional piece of information, in this case, is this f of 1 is equal to 9. And that extra piece of information is called an initial value or an initial condition. And so we're going to use this extra piece of information to figure out what f exactly is. Okay, so let's write this down. So f here, it says, f of x, big F of x, is the antiderivative, or is an antiderivative of little f of x, which means big F of x is this thing. Okay. And so we can do this by our power rule. So this is going to be 6x cubed over 3 plus 6x squared over 2 plus c. So f of x is equal to, and so that's going to be 2x cubed plus 3x squared plus c. Okay, and so before we go on to the next page and finish this problem, I want to point out I'm really sort of abusing this equal sign here in the sense that this is not the answer to what big F of x is. Because actually on the other side of this equal sign, there's infinitely many equations because this big C could be any number. And so what I'm really saying here when I write this equal sign is I'm really saying there is some c, I don't know which c it is yet, so that f of x actually is this thing for whatever that particular value of c is. So what we have to do now is we have to figure out what that value of c is. And the way we're going to figure out what that value of c is by using this initial condition that we were given. And so what I'm going to want to do here is use the fact that f of 1 is 9, but f of 1 is also what I get when I plug in 1 to this equation. So let's write that down. So f of 1 is actually equal to 2 times 1 cubed plus 3 times 1 squared plus c. But again, it's also 9. Okay, and so what I'm doing here is I'm putting together both this formula for big F of x and the fact that I was given in the problem that f of 1 is 9. Okay, so I can simplify this. So this is 2 plus 3 plus c, and that's equal to 9. So then c is 4. So that gives me my answer, that the function f of x that I'm looking for, it is the function 2x cubed plus 3x squared plus 4. Okay, and so what we just did is we figured out, of all the antiderivatives that little f has, all infinitely many of them, the only one that has this property is this particular one. Okay. Let's do another example. So let's here do, and so I'm going to phrase this slightly differently. So if f double prime of x is sine of x plus cosine of x, and f prime of 0 is 10, and f of 0 is 6, what is f of x? Okay, so what you'll notice here is that I've given you the second derivative of little f, and I want to find little f. So in order to do that, I'm going to have to integrate twice, because the integral is undoing the derivative. But that's going to introduce some constants, as we'll see. And so I'm going to need these, again, initial conditions here to find the value of those constants. Okay, so let's do this. So f, or f double prime is sine of x plus cosine of x. So because f double prime is sine of x plus cosine of x, that means that f single prime of x is the integral of sine of x plus cosine of x dx, which is the integral of sine is minus cosine of x, I'll remind you from the last video, plus the integral of cosine of x is just sine of x, plus c. Okay, again, I did the integral to undo one of the two derivatives on f. But I'm not done, I still have to undo the other one. So f is now the integral of minus cosine of x plus sine of x plus c dx. And so the integral of minus cosine is now minus sine of x, plus the integral of sine is minus cosine of x. Okay. Now I have to integrate this arbitrary constant. Okay, so remember this c I'm thinking of as being c times x to the 0th power, so that I can use the power rule, so that the integral of this constant is now c times x. Okay. Again, just like when we've in the past done something like the integral of 7 is 7 times x, c is just some number. I don't know what number it is yet, but its integral is cx. But I just integrated, so now I have to add an arbitrary constant. Now, normally, my arbitrary constant would be c. But I already have a c, so if I put another c, that's not really an arbitrary constant. So I need a second arbitrary constant. So I am, for lack of creativity, going to call that second arbitrary constant d. Okay. So this is my little f of x. Okay, but in the same way as before, I'm slightly abusing this equal sign by writing it here because this thing on the left-hand side of that equal sign is not one function. It's a whole bunch of functions corresponding to the fact that there's a bunch of possible values of c and a bunch of possible values of d. Okay, so what do I do? Well, to finish the problem, I need to go back and make use of my initial conditions. So I'm going to put that there so we can remember our initial conditions. And so then I'm going to write down, and I'll write down this one for f of 0 first. So f of 0 is minus sine of 0 minus cosine of 0 plus c times 0 plus d. But that is also, we're told, 6. Okay, so sine of 0 is 0, cosine of 0 is 1, c times 0 is 0, plus d is 6. So what does that tell me? Capital D is 7. Okay, so that gives me that piece. Okay, but I was also given an initial condition about the derivative at 0. Okay, so then I have to rewind time a bit and go back to where I wrote down the derivative. That was back here. This was f prime of x. And so now I have to remember, apologies, this is getting a little messy with all these sheets of paper running around. So now I have to hold in my head two things at once. I have to remember that f prime of 0 is 10, but also that f prime is this thing. So f prime of 0 is, okay, so it is minus the cosine of 0 plus the sine of 0 plus c, and that is supposed to be 10. Okay, so now I can put that up there. So writing this down, that is to say minus 1 plus 0 plus c is 10. So c is 11. Okay, so c is 11, d is 7 in this formula for f of x. So now to finish off, little f of x is in fact minus sine of x minus cosine of x plus 11x plus 7. Okay, and now finally, I have a very specific function that is equal to little f. And so that is my answer to this initial value problem. All right, we'll wrap up there for now, but we'll have more next time when we'll talk about some sort of multiple choice questions along these lines. But until next time, be well.